Graph the following linear inequality in two variables. 3x minus y is greater than 6. So remember, this is a two-step process when you have these inequalities involving x and y. Step 1 is to draw the graph of the line where 3x minus y is equal to 6. And I think the easiest way to draw that line is if you stick in 0 for x, you get negative y equals 6, so y equals negative 6, and that gives you the point 0, negative 6. And if you stick in 0 for y, you get 3x minus 0 equals 6, so x equals 2. That gives you the point 2, 0. So now that we have those 2 points, we draw the line that goes through those 2 points, but I've made it a dotted line. Remember why? When you have just a greater than without the or equal to part, you make it a dotted line or a dashed line to show that the points on the line, which would be where 3x minus y is equal to 6, are not included. Now part 2 is where we have to shade in everything on one side or the other of that line. The way we decide is we can pick a test point like 0, 0 and see if that works in the inequality. If we plug in 0 for x and 0 for y, we get that 0 is greater than 6. Now that's not true. So the point 0, 0 is not part of the solution set. We don't want to be over here on the side that includes 0, 0. Instead, we want to be over on the other side of the line, so we shade everything over here to the right of that line, and that's the solution set. Number 47, now here we have a system of linear inequalities. We have 2 of these at the same time. So first I'm just going to graph the first one, then I'm going to graph the second one, and my final solution is going to be the overlap what those 2 graphs have in common. So first of all, for y less than or equal to 2x minus 2, the boundary line would be the line where y is equal to 2x minus 2. And because that's in slope-intercept form, I see that that would be a line with a slope of 2 and a y-intercept of negative 2. So if I start at negative 2 on the y-axis, and then have my rise over run be 2 over 1, so I go up 2 and over 1, there's that line. I'm making it a solid line this time because it says y is less than or equal to 2x minus 2. So I am including the points where it's equal to. Then we have, well, the points where y is less than would be everywhere below that line. Whoops. So I want to be on or below this particular line for the first inequality to be true. Now for the second inequality to be true, the line where y equals x plus 1 has a y-intercept of 1. It has a slope of just 1, so up 1 over 1 for rise over run, that gives me this line. And for y to be greater than x plus 1, we want to be above that line. So putting these together, if we want them both to be true, we have to be on or below this line and also on or above this line. So that puts us in between the lines in this region up here that I've got shaded. Number 48, solve by the square root property. So this says something squared equals some number. And when you see something like that, you can say, okay, the something equals plus or minus the square root of that number. So 8 minus 8, x minus 8 squared equals 19, means that x minus 8 its own self equals plus or minus the square root of 19. And to finish solving and get what x is equal to, we just add 8 to both sides, and x equals 8 plus or minus the square root of 19. So those are the 2 solutions. One of the things that x can be is 8 plus the square root of 19, and the other solution is 8 minus the square root of 19. And here's one to solve by the quadratic formula. X squared plus 3x equals 7. If I'm going to use the quadratic formula, I need to get everything on one side equal to 0 on the other side. So I start by subtracting that 7 on both sides, and I get x squared plus 3x minus 7 equals 0. Now I'm ready to pull out the formula and put in 1 for A, 3 for B, and negative 7 for C. And it looks like x equals minus b, so there's negative 3, minus 3, plus or minus the square root of b squared minus 4ac, so 3 squared minus 4 times 1 times negative 7, all over 2a, so 2 times 1. Now 3 squared would be 9, 4 times 1 is 4 times negative 7 is negative 28, and then 9 minus negative 28, that would be the same as 9 plus positive 28, it would be 37. So we're looking at negative 3 plus or minus the square root of 37 all over 2. Now we can't really simplify that any further. 37 is not a perfect square. We can't really do anything with the square root of 37, except if you wanted a decimal approximation, you could plug this into your calculator. But if you want the exact answer, this is as far as we can go. So the two things that x can be, the two solutions to this equation are negative 3 plus the square root of 37 all over 2. And then the other one is negative 37 minus, negative 3 minus the square root of 37 all over 2. So that's the end of the review sheet. Again, if you have any questions, anything you want me to explain in more detail or go over with you, please message me, ask me. Also, don't forget the folks at the Academic Success Center are there for you. And hopefully you'll be ready for the final exam. And hope you're all doing well, safe and well, and doing as well as you can under the circumstances.